Welcome once again to Tutors. We're going to resume on our special functions rules, and we're going to do our product rule today. The product rule, okay? And it's applied when you see two functions that multiply one another. We have u as a function of x multiplied by what? V as a what? As a function of x. Good. So if you have something like this, different functions that multiply each other, how do you differentiate them? And that's why we have a formula for that, which is a rule. Then the y dx becomes u multiplied by what? Dv dx. Okay? You will take this function, you multiply it by what? The differentiation of the other function, v, plus you take v like that, you multiply with what? Derivation of what? U dx. Good. Let's go into question. Okay, as you know that. Now, first example, example one, if y is equals to 3s squared multiplied by cos x. Okay, we have 3s squared multiplied by cos x. Now, in this kind of scenario and cases, the first thing that you need to look at is that we have two different functions, and the first function is our 3s squared, which is our u, and our cos x, which is our v. Good. They are multiplying each other, okay? So, and again, they're not like different functions. Not every time, like this scenario now, one is algebra, the other one is trigonometry. But let me tell you, you can have algebra and algebra multiplying each other. So it doesn't have to be, but they're just different functions created by multiplication sign. So the best way to differentiate them is what? Separate them into two functions, name them. Let u equals to what? 3s squared, and let v equals to what? Cos x. So we now learn to what? Because we want to substitute all these values inside this, okay? So we'll do everything straight. That's how I do my own. So you say du dx. So to differentiate this, what do you get? I tell you, when you have u and x, what you're going to write here is what? Du dx. So you have divided this guy. You have what? 2 times 3, 6x. 2 minus 1, 1. That's 6x raised power. X raised power 1 is what? Itself. So that's 6x. Then we have dv dx. So differential of cosine x, it's like that. Cosine x, the standard formula. So there's a table like that. Okay, standard differential table. Okay, differential of cos x is minus sine x. Good. Now we have all our four variables that we can substitute into this formula. Okay, into this formula that we have here, our product rule formula. Good. So now we'll substitute them inside it. So let's start. The y dx will now be equals to, what's the first one? U have it? 3s squared multiplied by what? I use dots, I take dot as my multiplication. All right, dv dx. What's my dv dx? Minus sine x. Minus sine x. Plus v, okay? Which is what? Cos x times what? 6x. Good. Which is my dv dx. And I've said earlier that anything you're multiplying with a trigonometric function, you're not multiplying it with the angle. Instead, it will be at the back of it, like the coefficient. Okay? So this will turn to what? Minus 3s squared sine x. Okay? Plus, this will not become cos 6x squared. Okay? So, but I know you know what it is now. So it will become what? 6x cos x. Yeah, this is our final answer, but we can go more to simplify further. Okay, that's the fun in mathematics. So 3x is common, so we factorize and we have minus x sine x plus 2 cos x. Okay, so if you open this bracket, you will get this back. So anyway, this or this can be your final answer. Okay, good. Now let's move into the second one. 2, given that y is equals to ln x open bracket s cube. But it's not every time you have open brackets, okay? But just have ln x dot s cube. Anyhow, okay? So you say let u is equals to ln x and let v is equals to what? S cube. Good. And you now say du dx is equals to the version of ln x is 1 over x. Okay? So it's one of the standard functions and derivatives that we'll treat later, okay, in coming videos. So dv dx is what? 3s squared. So based on what we have here, our formula, which you must put in mind, dy dx is what? U times what? Dv dx plus v times dv dx. So dy dx becomes u. What's our u? Ln x times 3s squared plus v s cube times du. What's our du dx? 1 over what? X. 1 over x dot 1 over what? X. Okay, good. So we have that this becomes 3s squared ln x plus x in x cube. We have what? X squared. Okay, so s cube divided by x is the square. So you have s squared open bracket 3 ln x plus 1. Good. This is our final answer. Good. Next, the third question will deal with the product rule. You can still go and solve more questions, test yourself better. So if y is equals to, let me say, tan x cos x. If y equals to tan x cos x. Now you see that these are two different functions, okay? Like they are both trigonometry, but they are different functions. One is tan, one is cos. Okay, good. So now there's a product behind that. Okay, good. So say let u is equals to tan x and v is equals to cos x. Then the u dx equals to sec square x and dv dx is equals to minus sine x. Good. So we say dy dx, use our formula, is equals to u dv dx plus v du dx. So let's substitute our value inside. So u times dv, what's my u? Tan x times dv times what? Minus sine x plus v cos x times what? Sec square x. So this gives us what? Minus tan x sine x. Okay? And it gives us what? Plus cos x sec square x. This can be a final answer, or we can also simplify further. Okay, good. So your own work to do is this. Try and do this and comment the answer in the comment section. So first work to do is giving us one, y is equals to ln x dot cos x, y is equals to 4s cube cos x, y is equals to 3s squared arctan x. Comment and the answers in the comment section. Yeah, thank you very much once again, and stay tuned and watch the next video with some question through.